Okay, so I have a couple more examples that I want to walk through here. So on this one, we want to find the volume of the solid bounded by the planes x equals 0, y equals 0, z equals 0, and 2x plus 3y plus z equals 6. So there's a couple of things going on here. One, we're not really given in a function of x and y, but we really are. We're just not explicitly given it, right? Namely this part right here, right? This part, we could just solve it for z. So this is 6 minus 2x minus 3y. And then, this is now a function of x and y. So that takes care of that problem, but, it is given to us like this sometimes, so it's good to be aware that we might need to do this. Secondly, it gives us sort of weird bounds here. So if we look at the region here, it's bounded by x equals 0 and y equals 0, so that's, that's all well and fine. That's these lines right here. Now the z equals 0 part, we want to kind of combine that with this one right here, because we want to know where is this region two-dimensionally, so that we can kind of get our bearings for where our bounds of integration should be. And if we were to project this down onto the xy plane, which is what we're looking at right here, what you do is you just make the z part equal to 0, right? Because if the z part's equal to 0, then you're just on the xy plane. And that happens to be one of our bounds anyway. So if we go ahead and let z be 0 here, we would have the line, so when z equals 0, we have the line 2x plus 3y equals 6. And then depending on if you want to do this in terms of x or in terms of y, you could solve this different ways. We can do this for x here. So that's going to be y equals negative 2/3 x plus 2 if we solve it for y. So the equation here, we have the y-intercept at 2, and then you go down 2 over 3. Okay, so this would be our line here, and then so this right here then would be the region that we're on. Okay, so this one we actually had to come up with the region kind of ourselves. So we, again, to project this onto the xy plane, which is what we're working with, this is where we set up our bounds of integration. We just let the z part be 0, and then we're bounded, then we pretty naturally get the entire region since we're bounded by x equals 0 and y equals 0 as well. So again, this is y equals negative 2/3 x plus 2. So we could go ahead and integrate from 0 to negative 2/3 x plus 2 first. Right, so our equation is this, 6 minus 2x minus 3y. So in this case, we would be doing it with respect to y first. And then for x, we would be going, we do need to actually figure that out, I guess, right? We're going from 0 to 3, which we can see easily enough from the graph here, but you might need to do some algebra to find that point. So that's just going to be where negative 2/3 x plus 2 crosses the x-axis. So you would just set it equal to 0 and solve for it. So if you did it in the other direction, then you would have like y equals negative 3/2 y, or x equals negative 3/2 y plus 3, I think. And then then this one would be going from, so then it would be going dx first, and then it would be going from 0 to 2 for dy. Okay. In this case, neither direction should be particularly complicated since the inner function itself isn't very complicated. So here it probably doesn't matter too much which way you do it first. And that's going to be 6y minus 2xy minus 3y squared over 2. Okay. And then we're going from y equals 0 to y equals negative 2/3 x plus 2. So go ahead and plug all this in. So 6 times negative 2/3 x plus 2, we're going to have negative 4x plus 12, I believe. And then minus 2. Let's just do it all at once here. So we have plus 4/3 x squared minus 4x. Okay. And then 3y squared over, let's just go ahead and write this one out. Probably going to need to, we're definitely going to need to FOIL that. Okay. So everything's taken care of except for this part. So we can combine what we have to negative 8x plus 4/3 x squared plus 12. So this one minus 3/2 times 4/9 x squared minus 4/8, right? X plus 4. Okay. Dx. And then we can go ahead and distribute the rest of that. Okay, so the 3 and the 9 will simplify a little bit. 2 and 4. So it's going to be 2 on top over 3 minus 2/3 x squared. 3 and 3 cancel. We'll have a 4 on top, so that's going to be plus 4x. And then we have minus 6. Okay. So then ultimately, it looks like we have 2/3 x squared minus 4x minus plus 6. Okay. So again, it's really easy to make errors here. I just always feel like I've made one. So I'll just keep going. Hopefully everything is good so far. Make sure I didn't miss any terms here. 12 minus 6. Yep, looks good. Okay, so go ahead and do the integration then. 2/3. Literally this will be 2/9 x to the third minus 2x squared plus 6x from 0 to 3. Okay, so 3 plugged in here would be 27, divided by 9 would be 3, so that's going to be 6 minus 18 plus 18, so those cancel, and then just minus 0, so we just get 6 here. And yep, that is the answer they get in the book as well. Okay, so again, you should be able to do this in the other direction just as, easily. This one was, I don't like to call these easy because there's a lot of algebra that you have to do here. And I know that part can be tricky, but when I use the word easy here, I just mean in terms of like, it's easier to integrate a polynomial than it is to like do integration by parts and all that stuff, right? Even though the algebra itself can be kind of challenging, of course, or at least tedious, if not challenging. Okay, so let's do one more here. Where this time we want to find the volume of the solid. Bounded above by f of x, y equals 10 minus 2x plus y over the region enclosed by y equals 0 and y equals e to the x, where x is in 0, 1. Okay. So the region enclosed is, again, the part that we're mostly focused on here. So this is the function that we're integrating. And then we want to look for what is the region that we're integrating over. Okay. So y equals 0, of course, is the x-axis. And then y equals e to the x would be this function right here. Okay. So this crosses at 0, 1. And then x is between 0 and 1. So at 1, y is going to be just e, right? So that may or may not be important. Let's see. So this is the region that we're on, though. Okay. So again, because the function is so simple itself, just a linear function, it probably doesn't really matter which order we do this in. If we switched it around, then you would have x equals the natural log of y, and you would need to adjust accordingly there, because you have to make sure you're not plugging 0 in to the natural log, right? So we'll go ahead and do the integral for the volume here. So since y is equal to e to the x, we'll go ahead and do that part first. So 0 e to the x, and then 10 minus 2x plus y dy dx. Okay. So this will be 10y minus 2xy plus y squared over 2 from y equals 0 to y equals e to the x dx. Okay, so that's going to be 10 e to the x minus 2x e to the x plus e to the x squared over 2. Okay. And then the other part is just going to be 0. Okay. So this all looks fine. That last one is something I want to call attention to. We will need integration by parts also, it looks like. Notice that this is e to the x squared, not e to the x squared. Okay, so e to the x squared is not the same thing as e to the x squared, because of basically the order of operations here. Even though with our exponent rules, these do kind of look like the same thing, but this is equal to e to the x times e to the x, which is equal to e to the 2x. Okay, so this is very different here. So an important distinction here, especially when it comes up on this part right here. So this is e to the 2x then over 2 dx. So the middle part, I won't go through the integration by parts again because we just did like that exact same one. So I'll just pull the answer out of there. So that's 10 e to the x minus 2 times x e to the x minus e to the x. Okay. This is what we just found x e to the x was integrated. Plus this one, you let u be 2x. So then you'd have e to the 2x over 2. So this is going to be e to the 2x over 4 now. And then we're going from x equals 0 to x equals 1. Okay. So we have 10e minus 2 times e minus e plus e squared over 4. Now we can't ignore the 0 term here. Minus, that's just going to be 10 because it's going to be e to the 0. Minus 2 times 0 minus 1. And that should be negated too, right? Because we're subtracting. And then minus 1/4. Okay, so this part's just 0. So we have 10e plus e squared over 4 minus 10 minus 2, so let's say minus 12, and then minus 1/4. And I'll just leave it like that because we can't really make that too simple anyway. I don't have the answer for this one, so again, well, I could check in Wolfram real quick. And yeah, it does look correct. So that's Wolfram Alpha, by the way, in case anybody wants to check their own answers. It's pretty much the only program I know that you could do like double integrals like this. I'm sure there's others, but that's the one that I've always used. So yeah, so again, so this one I think would be a good candidate where we don't even necessarily need the region, because everything's pretty much laid out. And in general, like if you have one as a function of the other, probably best to integrate that part out first. But again, you could switch this around as x equals to the natural log of y, and I would expect it to work okay. But you know, there might always be some caveats there, but yeah, so you don't necessarily need to draw the region, but that's always going to be helpful here to see exactly what region we're integrating over.